Let's look at a few fundamental things regarding this chapter. First of all, our special angles. Remember, you will be required to remember these. You will not have them on the data sheet. So our special angles include 30, 60, and 45. Now, an easy way to remember this is just to tell yourself that sine 30 is a half. So that means 1 over 2. Opposite is 1. Hypotenuse is 2. And then you can calculate the other one by using Pythagoras. Or you can just remember 1, 2, 3. But this is not a normal 3. It's square root of 3. Okay, so that's how to remember that one. With a triangle having two angles, that's the same. You've got an isosceles triangle, with these two sides both being equal to 1, and then the hypotenuse being equal to the square root of 2. Okay, then let's move on to our fundamental identities. We have two identities that's relevant for grade 11. And they are called the quotient identity and the square identity. First of all, the quotient, it says the following: tan theta equals sine theta divided by cos theta. Now let me just show you in principle that this is true. I'm not going to use values, I'm going to use definitions. So sine theta is opposite divided by hypotenuse, and cos theta is adjacent divided by hypotenuse. Now if you're dividing by a fraction, you can multiply by the reciprocal and it will still be the same, and these two will cancel out, and that will be equal to opposite over adjacent. And we know that opposite over adjacent is equal to tan theta. Therefore, tan theta equals sine theta divided by cos theta. The square identity states the following. It states that sine square theta plus cos square theta is equal to 1. Okay, so let's test that. Okay, so our left hand side is equal to sine square theta plus cos square theta. Sine theta is opposite over hypotenuse. So sine square theta is opposite of hypotenuse squared. And cos theta is adjacent over hypotenuse. And that means square in this case as well. So we will have opposite square plus adjacent square, both of them having the same denominator as hypotenuse square. But remember, we are working with a triangle, where if this is theta, this will be opposite, this one will be adjacent, and this one will be hypotenuse. And these definitions only count if it's a right angle triangle. So by using Pythagoras, we can say opposite square plus adjacent square equals hypotenuse square. Therefore, it will be equal to h squared divided by h squared, which is equal to 1. That then means sine squared theta plus cos squared theta equals 1. And those are the two identities that's relevant for